Hello, everyone. Welcome to another episode of Q&A about history of science and technology. So I see we have a variety of questions queued up, and happy to try and answer other ones people might have. Let's see. We have one here from Icy, who comments that I published several books since my book, A New Kind of Science, which came out just over 20 years ago now. And the question being asked is, has publishing technology and quality changed in the intervening time? Well, you know, a couple of things have happened. I mean, publishing as an industry has changed a lot, because it used to be the case that to get many copies of something out there in the world required investing quite a bit of money to have a printing press print them. And since the web came into existence, which had started to happen by the time the NKS book came out, but with the web, it's the economics of getting something published for the world to see is quite different. Getting people to pay attention to what's published is a different story, but the actual sort of act of having something out there which can have many, at least virtual copies that people can see, is a quite different story. Because it used to be the case that, you know, to publish a book would cost something in the tens of thousands of dollars minimum to just print, ramp up that printing press and actually print off copies of hundreds of pages of documents. But so that's changed. And of course, there are many dynamics in the way that books are distributed, the corner bookstore versus the web distribution versus the online bookstore and so on. That's all changed. In terms of the physical production of a book, one thing I find interesting is that the value of presenting information in book form has still been maintained as far as I'm concerned. And one of the things that I like about books is that when you have something as a book, you can kind of viscerally tell that's everything it's talking about here. It's not a question of having links where you might follow this link and then there might be another link to follow and then another one. You don't really know how big the octopus is, so to speak. With a book, there's kind of a very definite, there's this thing, I flip through it, I'm going to tell how far I am from the end and so on. Now, obviously, that's emulated in lots of ebook kinds of publications and formats. I still find it very, nice to have the physical book where I can flip through it and get that same kind of experience. In terms of the production of physical books, yeah, there have been a number of changes. I mean, print on demand has become much more viable and of much higher quality. It had been the case that you were either using kind of xerography, photocopying type technology, or you were using offset printing, and that those would give two very different qualities of output. Those things have now almost, not completely, merged. I mean, to produce a book like the NKS book that was printed at very high resolution and so on, that's not possible yet in print on demand, even 20 years later. But to produce a book that is of more typical resolution and so on is possible with print on demand. It's also become the convergence of the price of black and white and color printing has happened, so it becomes much more realistic to print many more kinds of things in color. I think the dynamics of that have had the effect that when it used to be the case that, excuse me, it used to be the case that when you were going to print something, you kind of had to make the commitment that you were going to print lots of it, because it cost a lot to set up the printing plates and to kind of initiate the process of printing things. With print on demand, you can print just one of it, and the amount that it costs to print 5 of it is roughly 5 times the amount it costs to print 1 of it. There's not sort of an initial startup cost that has to be amortized across the number of copies that you make. So that's but I think in general, the quality of books as printed on a printing press has it's sort of still exceeds the the quality of our eyes to be able to see higher resolution. So that's kind of the max that one's reached there. And now it's only a question of whether the kind of print-on-demand mechanism has reached the same point. Let's see. Oh my, there's a question here about the history of fluid mechanics, how the Navier-Stokes equations were discovered and how they work. I'm not sure I know this history all that well. The question of sort of how fluids flow, the Bernoullis looked at that in, I think, the 1600s, leading to these principles about pressure versus velocity and so on. Then I think the early 1800s, people started thinking about fluid mechanics as something to which you could apply the laws of mechanics. I mean, in the early days of mechanics, people were most interested in things like solid bodies and talking about, well, motion of planets, things like that. Eventually, the rather elaborate equations of the motion of things like tops, things that were sort of relevant to the Industrial Revolution, and things that were, stresses and strains in iron structures, things like this. Those were things that were studied in the context of solid mechanics. As the 1800s kind of rolled on, by the 1860s, people were interested in things like molecular dynamics, of thinking about how lots of molecules bouncing around would, obeying the laws of mechanics, what the aggregate effect of that would be. I think the Navier-Stokes equations and things like that were in the slightly earlier part of the 1800s. And I think one of the things that have been done there was Poiseuille's equation, which is the equation that tells one the rate of flow of fluid in a tube, fluid with a certain viscosity in a tube. And I'm not quite sure when the concept of viscosity, the kind of the sort of resistance to motion in a fluid, the analog of friction for a fluid, when that was first studied, people certainly observed that water pours more easily than syrup pours, but the measurement of viscosity as something that would characterize the sort of flowing of fluids. When you put a certain pressure on a fluid, how much will it flow? I'm not sure when that really took off. Now, the Poiseuille equation was for the amount of fluid given a certain pressure of fluid, how much fluid would flow through a tube. And that was, I think, originally studied in connection with the rather gruesome question of, if you sort of cut open the artery of in a horse, how much blood will flow out of it. Now, by the way, ironically enough, blood is a very strange kind of fluid, not least because red blood cells are this kind of flexible, kind of flying saucer-like shape that gets deformed and so on as it goes through. It gets aligned with the flow. It deforms as it goes through small capillaries, things like this. So it's a somewhat peculiar kind of fluid that is not a Newtonian fluid. There's a clue for me about when viscosity first got discussed, because I'm guessing Newton, I don't actually know specifically where he discussed this, but I'm guessing Newton must have discussed viscosity, because the most common form of type of viscosity, that the shearing force leads to a certain velocity, that is called Newtonian flow, and sort of the different thing that happens with materials that don't have this kind of linear dependence of flow rate on shear force. Those are called non-Newtonian flow. So I'm guessing Newton had discussed the idea of viscosity somewhere, perhaps not unrelated to what Newton discussed in his law of cooling, that says that a thing, his estimate was that the rate at which something cools is proportional to the difference in temperature between the thing and the surrounding air. In reality, there are different forms of cooling depending on whether there's convection of just the air, kind of hot air rising from the object or coming off the object and being exchanged with the environment, versus forced convection, where you're kind of blowing across something. Forced convection is more like the Newtonian version. Free convection is more like a 5/4 power, I think, of that temperature difference. But so I guess Newton must have known about viscosity. I don't know at what point. Oh yes, actually, there was also work done on the shape of liquid drops, and that will have been something which made use of ideas of fluid mechanics, and that was certainly happening by the mid-1800s, because people were discussing both liquid drops and things about the formation of planets and so on from kind of fluid-like forms. The Navier-Stokes equations have, well, they have different terms that probably came in different times. There's the main term, the inertial piece. It's the time rate of change of velocity plus v dot grad v. That's a nonlinear term that is quadratic in the viscosity, equals eta del squared v. So eta is the viscosity. There's also a density, which I omitted on the left-hand side, so that what actually appears in sort of the ratio of these terms is the so-called kinematic viscosity, the ordinary shear viscosity, divided by the density of the fluid. But the right-hand side, the del squared v thing in the Navier-Stokes equations, that's a representation of viscous flow, and I think that might have come in earlier than the representation of sort of inertial flow on the left-hand side. But essentially what happens in the Navier-Stokes equations, they describe the velocity in fluids, and the right-hand side describes the tendency of fluids to just damp out velocity. So you start a fluid running, and the sort of effectively the friction in the fluid, the analog of friction for a liquid or for a fluid, will cause that motion to get damped out. The left-hand side is about, if you start something in motion, it will continue. It has inertia to continue that motion. And so, for example, that's what tells you that an eddy that you start off in a fluid will keep going as an eddy. Now, that left-hand side has, well, the combination of these two pieces has much more complicated effect that, for example, roughly makes a big eddy tend to break up into smaller eddies and still smaller eddies, until eventually the eddies are small enough that they get damped away by viscosity. But this cascade of eddies, that was an idea of Kolmogorov's from the 1930s, I think, as a kind of way of describing turbulence in fluids, this sort of apparently random motion that you see in fluids. That's something that comes from that inertial part of the Navier-Stokes equations. And the ratio of kind of the inertial term to the viscosity term is called the Reynolds number, and that sort of characterizes the nature of flows. And that was Oswald Reynolds, right, in the late 1800s. So again, people studying fluid dynamics, but I think Reynolds mostly observed that if you look at sort of a bigger but slower thing, then it will have the same pattern of fluid flow as a faster but smaller thing. That all that matters is the Reynolds number, which is a ratio of velocities and lengths and viscosities and so on. So I don't know this in as much detail as I would like. The more recent history of fluid mechanics I know better. But oh gosh, well, let's see. I mean, fluid mechanics, as it developed in the 1900s, people sort of had the basic equations, and then there was a big push to sort of find solutions to those equations. And so in the case of laminar flow where everything is smooth, where there isn't turbulence, there's not this sort of a random motion and so on. In the case of laminar flow, the big push, I would say in the late 1800s, was to find exact solutions in terms of various kinds of mathematical functions. And so, for example, Stokes found this thing it's usually called Stokes flow. And for example, if you look at flow past a sphere, you can work out exactly what the drag on the sphere is associated with the motion of fluid around it, 6 pi eta AV, as I recall. And that's a nice kind of traditional sort of 19th century mathematical physics calculation. To know what happens when the flow is faster, and when you start getting, for example, vortices that break off behind the object, that becomes much more difficult. And things like vortex streets were observed forever, but there still isn't a good analytical theory of those things in terms of traditional mathematical functions. Now, it has to be said, in the people had wind tunnels, and they had kind of visualization of fluids, certainly in the 1800s. I think there was a big boon in the making of wind tunnels and other fluid mechanics experiments in the 1930s. Strangely enough, it seems like a bunch of large wind tunnel and fluid dynamics labs were constructed at that time in the US as part of the WPA Works Program Administration, I guess, sort of finding work after the Great Depression plan. One of the things that was done during that time was, let's go build wind tunnels. And so a bunch got built, which are often still in use today. So that led to kind of the ability to study in the lab various kinds of fluid mechanics. People had been interested in sort of empirical fluid mechanics from the time when people were making kites to the time of the Wright brothers, and to the time of other kinds of aeroplane discussions, so to speak. I just saw actually a rather charming picture, talking of kites, of Alexander Graham Bell was a lover of exotically shaped kites, and one that I just saw a picture of was a three-dimensional fractal Sierpinski tetrahedral kite that he had in the very beginning of the 1900s, I think, that he was flying. And actually, it's strange because I think that time is comparable to the time when Sierpinski was first talking about those fractal patterns, and when people like Menger were talking about Menger sponges and three-dimensional kind of fractal patterns. And just a little bit after, when Georg Cantor was talking about Cantor sets as the sort of which later became sort of identified as sort of a minimal example of fractal kinds of things. But in any case, I think that the interest in wind tunnels and sort of understanding fluid mechanics more scientifically certainly was there even from the first aeroplane experiments. And I think the Wright brothers had a wind tunnel, if I remember correctly, in which they could test wing designs and so on, where you're blowing air across this design rather than having to take it out and make the thing go fast in the air, so to speak. You're blowing air past the design. I think that the sort of development of ideas in fluid mechanics and the study of kind of wing designs and so on developed through the first decades of the 1900s, and by things had gotten fairly sophisticated by the 1930s and 1940s. There were a whole variety of labs popping up, particularly as jet engines started to be developed. There were, the Jet Propulsion Lab in Pasadena, California, was coming into existence. That was and there were a lot of people who had come out of, there was a lot of work done in Germany before and during the Second World War on fluid mechanics kinds of things. There was also sort of competing work Famously, there was work done on things like the design of the wings of the Spitfire plane in England, where one of the things that happened was the use of kind of numerical methods to find approximations to the fluid equations. Previously, sort of the choice had been you either find an exact solution with mathematical functions or you test the design in a wind tunnel. This was kind of the beginning of numerical computation, where you just found a numerical approximation to the behavior of fluids and used that to make designs. The original work done by, I think, Richard Southwell, if I remember correctly, was done having humans be the ones who divided up the wings into a grid of squares and then worked out if the fluid was flowing at this rate on this square, then it would be flowing at that rate on that square on the next step, and so on. Of course, that by the time, by about the late 1940s, 1950 or so, those kinds of things just starting to be done on computers. Early effort in that regard was von Neumann and Charney working in 1950 on the first numerical weather prediction, taking the equations of fluid mechanics and putting them on a digital computer. I think it's sort of interesting, and maybe not to the point here, sort of what progress has been made since then. There have been, the Navier-Stokes equations are fundamentally hard to solve. And they're hard to solve because you end up with a wide range of scales of behavior. So for example, those eddies that I was mentioning, you could have a very big eddy that's the size of an airplane, and it can get broken down into very little eddies that are like an inch across. And there are a lot of those that fit in the size of a large airplane. And you have to kind of model all of those to be able to figure out things about the flow around the airplane. And typically on a plane has a Reynolds number of about 10 million for a big plane. So it has above Reynolds number about 100. Usually get turbulent flow, so it has lots of turbulent flow, but it has also a lot of flow that is that you can approximate without viscosity. But like 1 inch above the wings of the plane, you get this boundary layer where lots of features of viscosity really matter, and half the drag on the plane is probably associated with what happens in that 1 inch layer. So it's kind of a complicated thing to model because you've got to be able to deal with all these different scales of behavior. And there are lots of kinds of empirical approximations that have been done for sort of doing engineering, for aeronautical engineering and so on. There are lots of approximations that have been made that work fairly well, but they're not deeply principled versions of sort of a correct modeling of the Navier-Stokes equations. Usually what's done is to add what's called an eddy viscosity that is supposed to be a way of approximating all this randomness and the turbulence with something that's sort of an empirical kind of thing. And it has to be said that a lot of the work that's been done on things like numerical fluid mechanics has been done in a very engineering-oriented way. Of just the important question is to get an answer that is practically useful for studying actual flows around planes and things, not understanding the principles of how turbulence works with the Navier-Stokes equations. I myself worked on that second question quite a bit in the 1980s. It was very frustrating to find that the Navier-Stokes equations, one didn't really know many very basic things about them. Like, for example, does it matter in the end that fluids are made of molecules? Well, usually one imagines one could just approximate fluids by these continuous equations, but does it matter, for example, in understanding turbulence perfectly, does it matter that in the end, there's these little sensitive effects that will be associated with molecules that might get amplified into some of the randomness and turbulence, or does that not matter? And that's still not known. I mean, that's sort of a key, it's related to sort of a key unsolved problem about Navier-Stokes equations and about mathematical physics in general. But when I was working on this in the 1980s, my main idea was to not start from these continuum Navier-Stokes equations that describe the continuous flow of fluids, but instead start with something that approximates the underlying molecules, start with a little grid of where molecules might be, a cellular automaton, and then look at sort of scaling that up and saying, if the grid is big enough, we'll get something that approximates what we see in the real world, as an alternative to saying, let's take the continuous equations and let's, to put them on a computer, break them down into discrete numerical pieces. And that approach of mine has had some success in studying various kinds of things. I think it still has more to run in terms of understanding sort of what it means about the foundations of turbulence. And you can see with that approach that sort of the origin of randomness in turbulence is not the little details of molecules. It rather is kind of the overall kind of dynamics of the sort of computation that makes the fluid flow. In a sense, I view turbulence as one of the places where computational irreducibility, where sort of sophisticated computation is immediately visible, so to speak, in the world. And that's something you see from these models. You don't really get to see that very well from the Navier-Stokes equations. There's lots more to say about this, but let me not go on with this. I see a question here about UFOs from Kermit here. Do I have any thoughts on UFOs, and how should one engage with conspiracy theories or alternative science, these kinds of things? You know, it's funny, I got talked into, well, no, actually, I was, got invited to be part of a group that's trying to study what these days is more delicately called unidentified aerial phenomena rather than unidentified flying objects. And the idea is to just have a bunch of devices that are cameras and radio receivers and audio receivers and so on, and put a bunch of these devices around the US, kind of looking up into the sky, and just record continuously from them and just see what's out there. And actually, I just saw, what was it, a couple of weeks ago now, the first demo device from this project that had been constructed. It wasn't terribly sophisticated yet, had just infrared cameras and various kinds of radio receivers and so on. And I think it's just now being put into operation. And I think it will be kind of interesting to see kind of, if you just start observing sort of 24/7, 365 days a year, sort of what's up there, what will you see? Well, you will no doubt see a variety of meteorological phenomena that have not been well characterized. You'll no doubt see the occasional weird experimental aircraft that one didn't necessarily know was out there, those kinds of things. Will one see the strange kind of sort of UFOs of from the 1950s type things? Well, you know, when you talk to people about this, people will be very convinced that they've seen kind of, you know, flying saucer-like objects, and that they've seen things that glow and things that move too quickly to be things that would be any kind of propulsion that we know how to make, those kinds of things. What do you make of all this stuff? Well, you know, I think it's one of these kinds of things where one shouldn't dismiss it out of hand. One shouldn't immediately rush to conclude that, you know, the extraterrestrial alien intelligences are here watching us and have been for the last 50 years or something. But I think when there are phenomena, particularly ones that are somewhat repeatedly reported by people, one has to think that it's something. You know, maybe it's some strange meteorological phenomenon. Maybe it's something about some quirk of human perception in the case of some atmospheric phenomena. I mean, one could say, gosh, you know, there's a rainbow. How could there possibly be a rainbow? You know, the rainbow must be some special new kind of microorganism that's in the, you know, in the air producing different colors. But of course, we know that it's not. But rainbows are something which are, well, not formed as a matter of human visual perception, but certainly closely related to that. I mean, they're formed as a result of total internal reflection of light in raindrops and the different refractive index, the different bending angles of light of different colors, different frequencies in raindrops. But it's still something where the imaging of a rainbow is not a totally obvious thing. The fact that you can form an image of a rainbow is something that does depend on kind of the way that we image things. Same with other kinds of phenomena like mirages, like the glory, another type of sort of a circular rainbow-like thing that you can see looking down on clouds from airplanes and so on. So, you know, I think there are plenty of phenomena which can be interesting to see, and where one of the trickinesses, I would say, is that there are phenomena that are visually detectable, but really depend on the observer. So another one that's sort of an example of that is shadow bands in total solar eclipses. I've seen 2 total solar eclipses in my life. Kind of interesting phenomenon to see. But one of the things that's been reported in total solar eclipses is that right before totality, if you look down on the ground, there's this kind of shimmering that you see, where there's kind of this the sort of dark and light shimmering bands. So one total solar eclipse that I saw, I didn't see that. The other total solar eclipse I saw it. And it's like I had my phone. I was trying to take a video of it. The video was basically blank. It was a phenomenon that is, for whatever reason, perceptible by humans and possibly part of human visual perception, but not very easy. I think it has been captured by standard CCD cameras and things, but it isn't easy to capture that way. So again, that's a place where things can get kind of funky in terms of what people think they see versus what cameras pick up and so on. Now, in what should one do when people earnestly tell one that they are convinced that, in fact, I was at this event just a couple of weeks ago, and somebody with perfectly sober person was sort of rather guiltily telling me, well, one afternoon they had seen, basically a flying saucer. And, when I asked sort of what shape is it? Well, they said, well, it really was a flying saucer shape. Certainly, my sort of, at a human level, that person definitely believes they saw that thing. And that was their perception, that they saw that thing. Now, what was it? Was it a visitor from Torsetti in a conveniently saucer-shaped spacecraft, or was it some meteorological or atmospheric or visual perception phenomenon? Well, hard to know for sure. I would bet against the saucer-shaped spaceship from Torsetti. But I would say that an interesting thing about science and the dynamics that it has is there are things people start to believe, and then everybody kind of believes that, and even if it isn't true. So, there have been plenty of times in the history of science. I mean, one might say in modern times, certain aspects of what people believe about quantum computing is kind of, charming for the fact that there's a giant herd that believes it, and there's a lot of sort of economic dynamics around that makes it sort of assumed to be true, whether or not the ultimate science can be picked away to be found to be correct. It doesn't mean that it isn't worth studying, because there probably are other very useful things about studying the formalism of quantum mechanics and sort of the physics of computers that aren't made from semiconductors and electronics. But the question of whether sort of the full brand of it really does things in a quantum way, I kind of doubt that that's really right. But nevertheless, that is something where the vast mass of people would just say, of course, that's right. Perhaps that's not the best example. I mean, I suppose there are some examples in medicine. One pretty famous one is the stomach ulcer story, where, back, I don't know, 25 years ago or something now, people would regularly say, "Oh, I'm having too much stress at work. I've got too much stress at work. That's why I have an ulcer, and I need to cut back on my stress at work. And my doctor is telling me to do that." There had been people who had said for a long time that things like that were an infection. I think a bacterial infection of some kind. But sort of the vast mass of belief was, no, it's a response to stress and so on. And it turned out in the end it was a bacterial infection, and that's it's a case where the masses didn't really quite have it right. Now, in these phenomena where you kind of there's a sort of a question in today's world. A lot of the conspiracy theories around UFOs and so on center around, does the government know stuff, or do governments know stuff that people in general don't know? And I think there have been different times in history where that's been more or less true. My guess is that at the current time in history, it's not very true. That there are few large secrets, so to speak. I mean, I think I'm reminded of something I think attributed to Machiavelli, that it's very hard to keep a big conspiracy secret. If there's only a couple of people involved, well, you might be able to keep it secret. But by the time it's a big thing that's affecting a lot of stuff, it's hard to keep it secret. I think that there are sort of a question actually of, why should, let's say that the government knew about whatever that means, because it's some particular part of the government, no doubt, knew about lots of kinds of, actually there are extraterrestrials dropping in every Tuesday afternoon type thing. Why wouldn't they tell the world? Well, it's I think the sort of a prevailing theory of that would be, well, in sort of a military way of thinking about things, if you don't know what to do about it, why would you tell people it was happening, so to speak? Because the obvious question would be, if it turns out the extraterrestrials visit every Tuesday and maybe the extraterrestrials are dangerous or whatever else, people would immediately say, so what are you going to do about it? And if you have no idea what you're going to do about it, better to not tell anybody it's happening and to not have that question have to be asked than to have everybody ask that question. But I think there are also, one can imagine, I think this, I tend to think that there's sort of a question of when you hear about things that seem completely wacky, sometimes they really are completely wacky. Sometimes there's a particular person who is confused in some way, has some sort of different view of reality in some way that really isn't something of general interest. I tend to think when enough people report sort of similar things, that there's probably something behind it. It may not be the big conspiratorial thing that people think is the most exciting thing that could be behind it, but there's probably something going on there. As I say, the something, I would put my bet on something perhaps not scientifically trivial, but not of profound scientific significance. But one can't really tell that until one's been able to kind of nail things down. There was another question that got asked here. If I can get my up. Let me see what's happening here. Has my computer decided to misbehave here so that I can't see any more questions? Very odd. That is very, very odd. Let me see. That's an interesting challenge. Okay, let me see what I can do here. Uh, Very odd. I lost my mouse. Hold on. All right, let's see. Computer survival skills. That's really odd. Okay, I can bring up anything that is keyboard navigable. I can bring up, but I have no mouse. Let me see how I can deal with that. Isn't there a suspicious correlation between the surge in UFO sightings since the 1950s that is associated with a surge of UFO movies during that period of time? Well, yes. There's certainly, one would suspect that the movies came first. I mean, I think that I don't think that the writers of the movies were deeply tied into the UFO sighting community. I think, so there isn't really a flow from that side. It's not like, I must say I was struck by, this event about unidentified aerial phenomena a couple of weeks ago, and there was a person there who was talking about these things who'd been involved in sort of the military side of studying UFOs, UAPs, whatever else. And I was certainly quite charmed that really was very much the kind of figure that you see in movies as the model of the kind of military person who's involved in the response to aliens and so on. I was particularly interested, having done a bit of work on the movie Arrival, which was an alien first contact movie that featured some sort of interaction between where really the military were in charge of the response to sort of the alien first contact. And I was kind of charmed to have a chance to meet in person somebody who was just very much like the characters portrayed in that movie. And I suppose kudos to the director and screenwriter and so on of that movie for having captured the something quite realistic about that kind of response. I think it's a very interesting question. If, in the scenario of that movie and others about sort of a convincing alien first contact, so to speak, what would happen in the world, what should happen in the world, what, I tend to think, I've talked about this at great length, this whole notion of extraterrestrial intelligence is kind of a flawed notion, and that there's sort of intelligence all over the universe. And it's really a question of, as I would put it in terms of our modern approaches to things, sort of how far away in real space is that intelligence? How incoherent with our way of thinking about things is the operation of that intelligence? If it's as close as cats and dogs, we can have some sort of form of communication. If it's as far away as the weather, it's hard for us to have sort of a communication with it. But notwithstanding that, let's imagine that there actually is alien intelligence that is close in real space, that really is well aligned with our ways of thinking about things, but it just hasn't happened to be very nearby in physical space. And one day it arrives in a spacecraft. And then the question is, sort of in that situation where things are close in real space, where we can understand what that is, but where there are differences, it's not It's not like, oh, I guess, your planet got seeded with the exact same sort of early life as ours did, and we've both grown up the same way and ended up at the same moment in history with, slightly differently shaped creatures, but basically all the same stuff. Assume that it's far enough away to be interesting, but not so far away that we can't understand what it is or how to recognize or communicate with it. So assume that happens. Assume also if it's coming in an interstellar travel spacecraft, it's a bit more sophisticated than we are because we don't have interstellar travel spacecraft yet, and it's not even clear what the sort of human dynamics of having such a thing to transport humans, as opposed to having some kind of automated device that we send out and that eventually, generations from now sends back results, where we probably say, oh my gosh, that had such a primitive computer on it. We can barely understand how it's sending things back. But independent of that, there's enough universality to computation that I would be confident that one still could sort of decode and understand the form of alien intelligence that will be on that spacecraft going out into interstellar space. But assume that sort of the interstellar spacecraft arrives and something sort of emerges from it, and it kind of says hello, more or less, in a way that we can more or less understand. What does that seem like to the world? There was obviously a time up until, well, basically through the 1700s, I would say, where there was still kind of certainly in the 1600s, there was many parts of the world that were unexplored to the folks who were at least writing the histories of what was being explored. Could there be a city of gold in the Amazon jungle? Could there be the lost city of Atlantis somewhere? Could there even be, the city of Troy somewhere that had been written about in Homer, but which one hadn't had sort of continuing evidence of? And I think there was sort of the mystery of what was out there in the world, and people were quite regularly sort of expecting to see things they'd never seen before. Well, it turned out Troy was real. The city of gold in the middle of the Amazon jungle, probably not quite. I mean, maybe it was some reflection of some Inca kind of thing. The city of Atlantis, well, we still don't know quite on that one. But, it was pretty routine to say there'll be creatures we've never seen before that are hanging out in some weird jungle somewhere, and or on the Bigfoot in the mountains somewhere, whatever else. People routinely expected that there would be discoveries and sort of new and unexpected things. Now, such discoveries do keep on coming in, because particularly, who knew that there were going to be sort of very sulfur-friendly forms of life in hydrothermal vents in the ocean, where people were initially, oh, it's way too hot for there to be life. We don't know, for example, whether there's life deep underground in the earth. There might be. It might be very weird. We don't know. We learnt that there's life in the deep oceans far below where light ever gets. We thought for a while all those fish were spherical, because when you take a thing that's a fish that lives under very high pressure and you pull it up to the surface, it kind of inflates like a balloon. But in fact, they're not spherical. I remember people explaining why they had to be spherical, one of those interesting science moments. But it turns out they're not spherical. They just seem to be spherical because they're spherical when they blow up like a balloon after you pull them out of the deep ocean and bring them to a much lower pressure. But I think that the thing that sort of this idea that there's weird stuff still to discover and weird life forms and so on is a thing that mostly we've decided that's not going to happen much more on Earth. I'm not even sure that's true. I mean, the archaea were discovered, 30 years ago or something, by oh my God, Carl. The thing covered by at microscopy and genomics, so to speak, rather than it's sort of that was a case where a new form of life was all around us, kind of like the way I think it's going to go with alien intelligence, that eventually we'll realize new forms of intelligence are all around us, so to speak, rather than you have to go out somewhere in space to find it. But I still, coming back to this question of what is it like when kind of the alien intelligence that we can recognize shows up? Well, obviously in earlier times in history, when kind of Western explorers showed up in places that had been previously isolated, that was a type of thing that feels a little bit like what the alien extraterrestrials might be like showing up now. And one knows stories of what happened when people showed up in the Americas or whatever else, and there were probably some good consequences and some bad consequences. One thing that I find surprising about many of those stories is how easy communication was to establish. One might have thought, oh, you're there in a place where there's no common language, but you don't really read about a lot of, oh my gosh, there had to be all this work done figuring out translation tables and making dictionaries and so on. Pretty much one gets the impression people managed to communicate. Now, perhaps that's because there's enough commonality in the human condition, whether you come from sort of fanciest Elizabethan England or something, or whether you come from sort of the indigenous peoples of the Americas or something, that even though the kind of state of development of, let's say, technology, other kinds of things might be different, and the kinds of cultural beliefs and interests might be different, but there's still enough sort of commonality in the basic human condition. Everybody, eats and sleeps and those kinds of things, and talks for that matter, albeit in different languages. That there's let me give you something that is nice to eat, or perhaps there's enough commonality of let me give you this shiny object that everybody thinks is cool because it's a shiny object and everybody thinks shiny objects are cool. There's enough commonality there that it's possible to establish communication, I would think, more easily than I would expect. So, but of course, that's just humans to humans. And of course, we've had a dismal record of establishing communications with other species living on our own planet. So that doesn't give one a huge amount of hope, I think, for sort of the alien intelligence situation. One might argue, well, look, we are, as we get more sophisticated, we're going to be able to communicate more easily. Well, okay, let's have that conversation with the whale, and then I'll be more convinced about that. We're not yet in a position to do that. Maybe we will be fairly soon, but we're not yet. And that would kind of make it something where I might be more convinced that the sort of the quotes more advanced version of something like us would have an easier time communicating with us. But again, there's so many hypotheticals here, because to even have the possibility of recognizing that it's a kind of a thing like us, as opposed to, oh, that was an interstellar rock. We say it's an interstellar rock. To somebody else, they say, look, there are all these, complicated electronic processes going on inside the rock. Didn't you know that's really a whole extraterrestrial civilization that's been hanging out on the rock, traveling from star system to star system for the last billion years? You just were too ignorant to notice all of those sort of electronic processes, which to someone else might read as this sophisticated civilization. To us, it just reads as there are a bunch of electronic processes in a rock. So, I think it's complicated. There are many sort of stacks of hypotheticals when you imagine something which kind of comes through physical space to visit us and is close enough to us that we kind of can really empathize with what it is. But again, it leaves one with the question of what would happen in today's world if that hypothetical came to be, and we kind of got confronted with, let's say, a more sophisticated civilization. I have to say that I think there will be a lot more. It's like when we look at computers and AIs and things, and AIs are able to do some things that are sort of more sophisticated than we are, but we don't as immediately become. It's kind of less. What can I say? The features of AIs that are alien are ones that we say, oh, we don't care about that. What we care about are the features of AIs that are deeply aligned with us. And those places where the AIs kind of zoom off into the sunset, doing things that are much more sophisticated in some sense than the things that we do, all those little details of how the inside of a machine learning system works. Those are things where we say, oh, those are just details of the inside of a machine learning system. We don't care about those. We only care whether the system says it's a cat or a dog in the end, so to speak. And I have the slight feeling that, if the sophisticated extraterrestrials show up and they're doing all this kind of stuff, and they've got all these kind of streams of, I don't know what, fluid that they're exchanging in this way, and they're making all these drops in the air, and they're doing all these elaborate things, let's say, and we'd kind of shrug and say, well, that's nice. I don't know why they're doing it. It's kind of cool looking, but who cares? There might be things that the aliens were doing where we would say, yeah, we've really wanted to do that. We've talked about that, but we haven't been able to do it. We know what it is, but we haven't been able to do it. Many of those things are things that have specifically showed up in things like science fiction. We've been able to imagine it, but we haven't been able to do it. We've been able to imagine teleportation, but we haven't been able to do it. Now, of course, what does that really mean? I mean, does it mean you scan the object, you break it down into atoms, you send a digital signal about it, you reconstruct it from atoms at the other end? That's kind of a very, that seems like a very prosaic form of teleportation, but, seeing it in action, that might be what would happen. And I think, and we might then say, oh, that isn't really teleportation, even though it has the effect of the thing that we've been thinking about as teleportation. But I think that, the real question is, will the aliens be doing things that we know we would care about, but we just haven't been able to do? Or would they be doing things that we just can't imagine why anybody would do that? And so they don't read as something that's relevant to us. I mean, it's, we might say, look at those aliens. They are performing all these rituals, which, look at them, they're doing this and they're doing that, and they're twiddling themselves around, and they're doing this kind of thing and they're doing that kind of thing. They must have some elaborate, cultural belief system that leads them to follow these kinds of rituals. And we sort of shrug and say, well, we don't have that belief system, so we don't care. But in fact, to them, those quotes rituals might be the kind of they might be the kind of the social media like clicking mechanism for the aliens might be something that is some, I don't know, physical motion type thing or something. They're swiping left or right or whatever they might be doing, and you see that as some bizarre sort of thing where we don't know what the point of it is, and so we just can't connect to it. All right, I have to solve this problem. I either have to give up for today, or I have to solve my. Oh, look at that! My mouse is back. Hello, mouse. All right, okay, that means I can go on just a little bit here. Okay, there are questions here about all right, Parker is commenting on an effect something I don't know about the Phoenix Lights event where thousands of people saw the exact same thing. Yeah, I mean, a lot of these unidentified aerial phenomena things, it's like a lot of people see the same rainbow. And that's not a UFO. The fact that a lot of people see the same thing means there's probably something to explain there. It might be something that is related to human perception. Many people can see the same shadow bands, yet they're hard to record properly. I think that I agree that there's things to explain. They don't necessarily, it would be a different thing to be able to say. I'd be very surprised if we could identify a thing and say that's that's kind of an identifiable sort of aliens like us spacecraft kind of thing. One of the things that also is worth saying is that there are, one can imagine all kinds of strange things that go on. Like, for example, supersonic planes produce sonic booms. People claim one might be able to reduce the amount of sonic booms from the shock fronts if one carefully shapes the plane and things like this. But sonic booms actually travel through the air quite long distances, and so they'll be sort of blown by the wind and things like this, and people will end up hearing them in places where it's like there's no supersonic plane going nearby, but yet there's this strange phenomenon that happens. And I can quite believe there are plenty of astronomical and atmospheric phenomena, kinds of auroras and forms of ball lightning, all kinds of things which we don't yet know about. And that's those are things that are interesting. They're probably not as interesting as we just discovered an alien civilization, but they might be interesting physics. Who knows? Ball lightning, this phenomenon where you can get this kind of glowing ball that forms and lasts for a few minutes and maybe bounces around a room and so on, and is, I don't know, a meter across or something like this. That happens sometimes in thunderstorms, a rare phenomenon occasionally seen. Probably that's some sort of plasma soliton-like thing that's a kind of a stable form of plasma that we don't otherwise know about. And it's probably a perfectly real thing that somebody could figure out eventually. Oh yes, once I see how it works, I can solve the magnetohydrodynamic equations and say, yes, that thing should exist. But I wouldn't have ever guessed it would exist without having seen one. So there are probably plenty of things like that. There's a question here about other notable phenomena that people thought they've observed that were not proven to have scientific validity. Example, alchemy. Yeah, alchemy is an interesting case. So I don't. I think that alchemy was something practiced in the Middle Ages, particularly kind of the idea that sort of an early kind of chemistry where you could make something remarkable from something unremarkable, particularly make gold from lead, for example. And I would say one of the things that's probably a trickiness in an area like alchemy is that it was probably the obvious payoff of making gold from lead is not the best influence on having sort of the most accurate science done. And I would say that with alchemy, it is a little surprising to me, and I don't know enough about the history of alchemy to know for sure that, in the end, it must have been possible to, somebody says, well, I made some gold. Well, of course, they could just have had the gold in their back pocket and they pull it out. My impression is that the sort of practices of alchemy really did turn into the practices of chemistry. It's just that the overarching story was a bit different. Now, I mean, the same can be said about astrology. Astrology was kind of a thing where, practiced in ancient Babylon, and where people were sort of foretelling the future by doing a variety of things, from looking at the entrails of goats to looking at sort of the arrangement of stars and planets and so on. And, you know, astrology, one branch of it turned into astronomy, because it was all about sort of, in the end, the predictions you might make might be predictions about where planets would be. And turns out one figured out how to make those using essentially mathematics. The other predictions about kind of, you know, who will win this or that battle, one didn't figure out how to make in the same kind of scientific ways. But I think there's a certain sense to me in which I imagine the ancient astrologers, and I imagine that they were basically strategy consultants for kings and so on, who were like kind of discussing, well, you know, what actually, you know, should you go to battle at this point or not? You know, let me be a consultant and give you an opinion about that. But the consultants had a certain amount of hocus pocus around them that involved, you know, extracting entrails from goats and making elaborate pronouncements. I mean, the same with the Delphic Oracle. You know, people would come from all over the ancient world to consult the Delphic Oracle. And there was, I think, a high degree of kind of sort of hocus pocus around that process. But in the end, and I think the Oracle, the Delphic Oracle, had the big advantage that people from all over the ancient world had come to see it. So, and come to see the people there. So they'd been hearing about, oh, you know, there's this person from Asia Minor who's worrying about this thing, and there's this person from North Africa who's worrying about this thing. It might have been the only place in the ancient world where all of those different kinds of, you know, all of the information from all those different places came together. So it made for sort of a good consulting opportunity. But I tend to think of the astrologers as being somewhat sort of, you know, wise consultants with a certain dash of hocus pocus. And I'm a little bit reminded of modern consulting, you know, some kinds of strategy consulting and so on, where people say, we're using the such and such method. You know, it's not entrails of a goat, but it's some other kind of branded method, so to speak, that sort of sounds cool. But really, in the end, it's like you're going to be able to get a good result if you have good judgment and you know, you think well and so on. And the hocus pocus part of it is just to bring those eyeballs to your website or whatever. And I think that might have been very much, well, I hate to think of the more literal form of dissecting creatures for bringing eyeballs to things, but let's not go there. From in the ancient world, but I kind of think it was the same sort of thing. I mean, it's kind of shocking to me the extent to which these kind of human features of, you say, oh, you know, the modern consultant is so different from anything that existed before. It's just not true. You know, these people like that were the people like that all over throughout history. I mean, like I mentioned, Machiavelli, he was a consultant, basically, a strategy consultant to kings and so on. You know, as many people in the ancient world were, for example. So I think that's you know, with respect to sometimes there are things like alchemy that last a long time, where some of their methods might actually have been exactly what was needed to refine metals and things like this, but it had a certain layer of hocus pocus that was all about turning, you know, lead into gold and so on, which didn't turn out to pan out. You know, I tend to think most of the time that when there are enough people doing something, that there's probably something interesting there, even if it isn't the thing that people have been sort of touting as the interesting thing. I mean, it's goes along with kind of the idea that, you know, when something notable finally gets done in the world, there's often something quite interesting and difficult involved in doing it. And it isn't just the kind of, and it often isn't the superficial, you know, oh, that person was so cool, so they could do this. It was some much more much deeper, much more intellectual kind of thing that made it possible. Maybe I can try and let's see. Well, there's one question that came in here about maybe I should address this a different time about independent science. Maybe I'll address it next week. It's sort of a bit different topic here. There's one question here. I'm going to try and address this. My last thing for today from Erin. How has your view of the future changed over the past 40 years? That is an interesting question. You know, first I've tried to test myself by trying to remember things that I thought would be the future and see whether I was right about them. I think you know, perhaps, well, over the past 40 years, I've seen a lot of things which were just murmurs of what might be possible turn into big things that were important in the world. And seeing that has been very interesting, because when I see a murmur today, the question is, will it turn into a big thing in the world, or will it just go silent? And I think that perhaps I've realized that sometimes the murmurs take longer than you could possibly imagine to turn into real things in the world. And I've also kind of realized that, I mean, a lot of stuff I've done myself, I kind of was thinking, well, people are going to really understand this real soon now. But I've realized that real soon is 50 years, 100 years. The timescales for the absorption of ideas are longer than I imagined. But what happens is specific kind of slices of those ideas, specific kind of, change life for the world in some specific way, those things come in quickly. But the sort of bigger intellectual sort of arcs take a surprisingly long time to come to fruition in my observation. I mean, I think there were things that I believed 40 years ago and believe today. I mean, it's kind of like computation is getting to be everywhere and is sort of the big story. I mean, today I kind of am pretty sure that it's computation all the way down in our physical universe. I think that this really is a sort of a key paradigm for understanding things in the world. And I thought that 40 years ago. I think that even more so today. Quite what the working out of that paradigm will lead to all over is not clear. I mean, to me, I think the thing that's happened is what's one of the things that's interesting about computation. It's a very general kind of thing, yet many of its applications have been very specific. Like we might be doing, video conferencing. That's being done on general purpose computers, but the actual sequence of operations that are being done is very specific to video conferencing. And the fact that there are all these things that ended up being these little sort of towers of capability that were made possible by what was basically sort of general computers is something that I sort of expected, but it probably happened more than I thought it would. I mean, of course, something like video conferencing is a thing for which there were murmurs, back from the 1960s, the 1950s, and before. I was certainly very well aware of it. And I was like, that's going to happen in the end. Just like, flying cars will happen in the end, even though, when they would happen wasn't clear. I mean, I was sort of a little bit embarrassed to find things that I'd done when I was a kid in the 1960s, where I was kind of assuming there'd be a colony on Mars by the 1980s or so. And that timescale was completely wrong. But, will there eventually be a colony on Mars? Undoubtedly. What is its timescale? Longer than I had ever imagined. I think that you know, in terms of the, you know, I think there are aspects of the future that maybe I understand with a little bit more clarity now that have to do with the sort of interface between technology and humans, and particularly the extent to which we humans in biology are an example of molecular scale computing, and the extent to which, when we can do molecular scale computing, we will have this quite different form of interface to our sort of human existence than we've ever had before. And I think that the that is likely to lead to all sorts of discontinuities in kind of what happens in the future that are, you know, quite unpredictable to me now. I would say that, well, 40 years ago, I was just coming upon this idea of computational irreducibility, this idea that just because you know the rules by which something operates doesn't mean you can kind of jump ahead and figure out what will happen. And the extent to which that would play out in kind of the unexpected in history, I actually knew that. I began to know that certainly by the mid-1980s. I was quite aware of that issue. Of course, I still sought to kind of predict things about the future, even though at some level I expected computational irreducibility to limit what I could really say about the future. But you know, I'm trying to think what other. I mean, it really is so interesting to see these things that start as murmurs and then become kind of all around us. And to go back, once something has become big, and to see there was a seed of that thing. And I suppose in my own life, one of the things I've tried to do is not ignore the seeds, and you know at least a bit about those seeds, even if I'm not personally involved in nurturing and growing those seeds, so that sort of when the seeds start to really emerge, I'm not completely surprised, like, oh my gosh, I never expected that it will be possible to, you know, transfer one voice to another using some automated AI system. Well, of course, I believe that's possible. You know, I've seen demos. It's not yet a routine thing to do, but it certainly will be possible. Or, you know, of course, it's, you know, there are things that involve just extracting information from ever and ever sort of more tenuous and finer details. You know, will it ever be possible to know every single time that, you know, some my computer has been touched through its history by looking at the precise configuration of atoms? Not sure about that one, but I think it's a maybe. It's definitely not a slam dunk no. It depends on lots of details whether that's possible. So in any case, I think yeah. So I'm trying to think what if you'd asked me, what do I think? What's the most surprising thing about today's world relative to 40 years ago? Well, many aspects of. I mean, I didn't expect. I didn't expect what the web has turned into. The concept of some kind of networked computer thing was very familiar with 40 years ago. The fact that I was even familiar with kind of personal computers, the fact that more people will be using computers over the course of time, but the kind of sort of lots of what happens in the world moves over into kind of the web sphere. I don't think I would have expected that. I don't think. I'm trying to, I don't think I really thought about it very much. I knew I used computers, I used email, I used these kinds of things. And if you'd asked me, would everybody be using this at some point in the future, back at that time, I probably would have said, yeah, I would expect so. You know, as computers get cheaper, et cetera, et cetera, et cetera, I would expect so. So, but I wouldn't necessarily have internalized sort of the major dynamics of sort of human affairs that have, not that they're that different from what happened before, but they're differently played out in this kind of web environment. I think that's, yeah. 10x comments. Most surprising is that so many people are using the internet for watching cat videos. You know, this is a funny thing, because I used to use cats as an example of amusing pictures of things forever. Maybe everybody did, I don't know. But, you know, I started making kind of, but long before cat videos became like a meme type thing, it just seemed like that was a fun thing to watch in a little snippet of video. It's a, you know, it's a cat video. I think, so it was really amusing to me when cat videos became such a big thing. I should probably find some of the things that I, you know, places where I used, you know, cat video as an example type thing. Yeah, I mean, that was the fact that, I mean, look, there are things that surprised me. Like an example is this. You know, one would think over the course of time that if one could have sort of very high resolution video, everybody will be into, you know, watching movies in the highest resolution video possible. And some people are, but also people watch videos on their phones. And I never thought that sort of the downgrading for convenience thing would be as significant as it has been. That is, even though it's tiny, might be fairly high resolution, but it's tiny and doesn't have sort of the same plush form factor as that giant movie screen, the convenience wins out over quality, so to speak. And yeah, that's a thing somewhat unexpected to me. Okay, and Alexander concludes here, maybe cats are the aliens. Well, yeah, I mean, this is the, you know, cats have an alien view of the world, no doubt. I mean, I haven't been able to talk to a cat to determine that for sure, but I'm strongly expect that cats, dogs, you know, dogs are using smell as a way to understand the world. That's a very different view of the world from the one that we tend to have. You know, there are no doubt, you know, the cat philosophy might be, you know, vastly different from you know, the cat. The cat condition is surely a bit different from the human condition. We share certain things with cats, but other things we don't share with cats. And you know, I think this is the big mystery. If we could talk to cats, how would the conversation go? You know, is the cat condition similar enough to the human condition that we could have a reasonable and interesting discussion with the cat? Or would the cat just be saying, you know, sort of squiggling mouse, straight mouse, you know, a long stream of mousiness, so to speak, that we just are like, I don't know what you're talking about. You know, just looks like a mouse to me, or whatever it is, or something about how it's you know, some kind of hunting concept. That has you know, where we'd be mystified. Now, we might be mystified if we were to trail some human hunter who is you know, paying attention to that strange little track or that strange sound that we don't necessarily notice. That might be a bit of a similar experience to, you know, talking to the experienced, you know, indigenous person somewhere who is a great hunter of this or that thing, and who knows how to kind of read the forest to know this or that. Might be an experience not unlike the experience of trying to communicate with, you know, with a cat or something who is very sort of concerned with hunting things. And, you know, we might have as difficult a time, but it might be an easier exercise because the pure mechanics of speech would be shared, and other aspects of the human condition would be shared. But it's sort of an interesting experiment, perhaps, to try and imagine what it would be like to be having a serious philosophical discussion with a cat. All right, I think that's a sign. By the time we're talking about serious philosophical discussions with cats, I think it's time to wrap this up. So thanks very much for all those interesting questions and comments, and see you again another time. And I think this Friday we have my doing it almost every week for the last 2.5 years, Science and Technology Q&A for Kids and Others. It will be the 100th episode of that coming up this Friday. So tune in if you'd like to see that. All right, great. Thanks, and bye for now.